There we go. You seeing that all right?
Yep.
Cool. Yeah, so two companies. One of them is lunasea.solutions, and that's a for-profit company that I'm the president and CEO of. We specialize in ocean tech development for data collection, data analysis, and distribution of data. Most of our products fit into the software as a service category, and we've got a few of them. I'm going to show Luna Ocean, which is basically a data portal, later in the presentation. And then SOAR, which is Sustainable Ocean Applied Research, is a not-for-profit organization that I'm one of, I think we're at 8 directors now, one of 8 directors. And we do applied research focused on working with coastal communities to find sustainable solutions and help with resiliency. A lot of the work there, again, has been in tidal power over the last about 15 years, predominantly in the Digby region, working in Grand Passage and Petit Passage, but also in the Minas Passage, including at the Forth site. We also provide marine services. We've got a fleet of vessels and several professional mariners, and have facilities based in Lunenburg and down in Briar and Long Island. So for the wave buoys that we've been managing, we've got 2 spotter buoys that we deployed both in 2021. The first one went in just off Cross Island, which is this one here. That's Cross Island, just outside of Lunenburg, in June 2021. And in November 2021, we put one into St. Margaret's Bay, which is right there. And here they are on the charts. Both of them are intended to be long-term deployments, so they've been added to nautical charts. The Cross Island one is here again, and then there's St. Margaret's Bay. Both of them are in approximately the units on these charts are meters, so approximately 50 meters, or 30-ish fathom of water to be outside the break zone. So these buoys are definitely in areas that are used by other water users, including fishermen. And and we've managed that essentially through working with them and providing access to the data. I think probably most of you are pretty familiar with the schematic, basically the way that a wave buoy goes together, but I added a drawing here anyway, for those that aren't, and in particular because I'm going to talk about this catenary line, which is the line that connects the main float to the wave buoy. The purpose of that is essentially decoupling the wave buoy from the anchor, so it's not feeling that, and it's free to move with the wave motion. At the bottom, I mean, we've got kind of a standard configuration of an anchor and a chain. We often add a clump weight for a little bit more purchase, and there's a bit of redundancy. We put a small float in line to get the connection point between the chain and the rope up off the seabed to reduce wear. We then use a section of floating line to further mitigate the risk of getting caught up on the seabed, and then we switch to sinking line for the upper part of the wave buoy to keep it down and reduce the risk of it getting run over by a boat. And typically have an OTN, Ocean Tracking Network receiver, on the buoys as well. And then there's the main float, which is primary purpose is buoyancy. That main float is shown here. It's the big orange one. And then, as I said, the catenary line going to the wave buoy. And the 2 pictures on the right, you can see the typical surface expression where you've got the orange float being the main one that's connected to the anchor, and then the wave buoy off to the side. So some of the issues or learnings that we've had to date. The most significant one was shortly after deployment of the Cross Island wave buoy, within the first month, we had a leatherback sea turtle entangled in the buoy. We spotted it through basically some strange data. It was registering really, really long period waves, like beyond what's physical for Nova Scotia, wave periods beyond 20 seconds. That led us to think that something had got snagged up in the buoy. I went out to check things out, expecting it to be like some seaweed or debris or something like that. And I found a very large leatherback wrapped up in the catenary line. So it had swam into it and twisted. There were multiple twists, making it tight around its neck and its right flipper. So yeah, the animal was still okay, like it was still quite lively. And yeah, me and the turtle spent about an hour doing disentanglement. I do have disentanglement training. I've been trained on disentanglement of right whales and humpback whales based on my time down in the Outer Bay of Fundy. So I was able to approach the animal and do it, relatively safely. And we both made it out all right. So the mitigative measure that we've done for that is instead of having a rope, instead of just a rope between the main mooring line and the buoy for the catenary portion, we've fed the rope through a rubber hose, which makes it way less likely to get wound up tightly, because a hose is really hard to twist up tightly. It's more likely to be able to come loose, and we haven't had any issues since. So that's one of the main things I wanted to kind of pass off in this presentation is it's essentially looking at ways to reduce risk of entanglements. Other than that, both of our wave buoys, the St. Margaret's Bay one and the Cross Island one, have gone adrift. The Cross Island one twice, the St. Margaret's Bay buoy once. The first time that the Cross Island buoy went adrift, we think it was entangled in fishing gear and just cut free. It was based on the timing of year, and a lot of gear got moved into the area. We don't know that for sure, but when we went out to recover the buoy, there was something relatively heavy at the bottom of the line. We went out in a small boat without any kind of hauler, and weren't really able to lift it up by hand to confirm what was down there, but it sort of felt like it might be a couple traps. And it didn't give out at any kind of normal wear point. So we don't know for sure, but we think that's what happened. The two times that it went, the other two times that the buoys went adrift, it gave out at the same point, which is a high wear point. I'm just going to flip back, and it's the connection point between the catenary line and the main float. Just wore through. And the mitigative measure for that is essentially more maintenance, and we've reinforced that point and haven't had any issues since. Both buoys are due for maintenance. So as I'm saying that, I'm thinking about the hurricane waves that are coming, and the fact that I should get out within the next month or so to check things and reinforce. So those are, that's the main things we've had happen. Other than that, we've got great data for over 2 years on one buoy and getting close to 2 years on the other. Moving forward, we've got a couple planned deployments. We've got a refurbished spotter buoy. It's got a bad sea surface temperature on it, but it's good for wave data, and we're currently thinking about different locations to put it. And we're in discussions with different fishing associations and recreational water users as to where to put it, and I'd appreciate some ideas from the group. Also working with the Confederacy of the Mainland Mi'kmaq and Mi'kmaq Conservation Group. We're part of a project that they have funded through DFO, where they bought a spotter buoy. Their project is focused on the Inner Bay of Fundy, where the tides are quite strong and strong enough that it would pull the buoy under. So we're planning to do it as a free-floating buoy, which the spotters often are. So it'll be tracked as it drifts around in the Minas Passage and Minas Basin and collects wave data. And in general, are looking for other opportunities to work together with interest in developing a network of near-shore buoys. This is my one slide that's got a lot of text on it, because we do put a fair bit of thought into location requirements. And this is sort of the thought process that we're going through for the new buoy. First one being a supportive and preferably helpful local community that would benefit from more waves data. Our focus is providing waves data to water users. So we're looking for areas that are of interest and high levels of activity for surfing, kayaking, going to the beach, sailing, other recreational boating, and of course commercial fishing. And it would be lovely to match that up with other research interests, of course. So in general, we're looking for exposed locations that get, good waves in most of the swell directions that are picked up on probably the eastern shore of Nova Scotia. We're looking. The minimum depth we like to put these buoys in is around 10 fathom, which is approximately 20 meters, and that's to keep them outside of the break zone and have enough depth for the different components of the mooring, including that catenary line that I mentioned before. Of course, it's nice to be relatively close to somewhere we can launch a boat for maintenance and recovery. We want to stay out of high traffic areas. So, like somewhere near an approach to a harbor is okay, but not directly in it. And we definitely don't want to be anywhere near the approach to Halifax Harbor. We essentially just don't want to have our buoy get run over. And one of the most important ones is sort of balancing the benefit to the fishing community to the inconvenience. And the footprints of these buoys are really small. I mean, it's similar to a single lobster trap, so that's pretty minimal. But if it's not providing any benefit to the fishing community, then it's essentially not getting balanced, right? I mean, even just a single buoy out there that people don't know what it's for or what it's doing, and it's not able to access the data can certainly be considered an annoyance. So our way of dealing with that is providing access to the data through the app, which I'll show in a minute, and generally talking with the harbor authorities before we put a buoy in the water and just talking it through with them, telling them how the data will be available and working with them to find a good location. So now I'm going to flip over to a quick demonstration on how to access the data through lunasea.app, which is a website. And if anybody wants to follow along as I'm doing it, I'll just give you a minute here to either type that website into your computer, or if you want to follow along on a mobile phone or tablet or anything like that, you can just scan that QR code. I'll just wait a few seconds before I change screens. All right. So when you load the app, if you don't have an account where you can set preferences and things, this would be pretty close to the first screen you'll see. Our default is it shows a global wave model, and wave buoys are the icons here, the red ones with the little wave icon, and water levels are the blue ones with the up and down. We're seeing a big red zone here. This is swell that's coming off Hurricane Franklin right now. And the little crosshair in the middle is essentially where you'll get a forecast if you click this gray button over here. So I think we might as well see what's going on with the hurricane waves to start. So I'll click there and the forecast should come up. Yeah, about 26-foot waves at 13 seconds there, heading towards our shore. We do a plot wave height and period together, and then wind speed and direction. And now I'll zoom in and see the two wave buoys. So the two buoys that we operate are, obviously on here, I've shown them before. There's the Cross Island one, and as I move closer, there's St. Margaret's Bay. But we're also pulling wave buoy data from other APIs. So there are Smart Atlantic buoys on here. All of the buoys operated by NOAA are on here, as well as a lot of the Canadian buoys. The buoy just outside of Halifax Harbor that's operated by Cove is on here. So it's it's a combination of basically all of the buoys that we can get access to from different APIs. Spotter ones are really easy for us. If anybody has a spotter buoy that they want to add to the map, we can do that quite quickly. And yeah, you just click on the Cross Island Wave Buoy here and it'll pop up. There we've got a plot of wave height and can switch over to wave period and direction. One of the really nice things about these buoys is it does give wave direction as well. And it gives peak period, as well as mean period, so two different measures. The wind speed and direction on these buoys is okay. They don't have an anemometer on them, so they're calculating wind information based on the wave spectrum. And those algorithms assume unlimited fetch. So it's good if it's in the open ocean, but any wind coming off land, it doesn't account for very well. And then sea surface temperature. So yeah, it's almost 20 degrees out there today. At some point in the next little bit, I'm planning to plot sea surface temperature over the last couple of years because it'd be interesting. So yeah, those are the wave buoys. One other thing I'll just show quickly, because it might be of interest to some people in the group, is that we have a really so controls on the app are this little blue button here with the lever. You can just pop that open. And then we've got layers, which are essentially from numerical models, and that's showing data over large regions. And then icons, which are point source data. So that's where our wave buoys are, tide stations, weather stations, river levels. We've got beaches, boat launches, all kinds of things. But the currents for the Bay of Fundy, if anybody works in there, might be of interest. So this is a high resolution model. We're providing data here at 30-meter resolution and 15-minute time steps. It's a numerical model from Acadia University that was developed over several research projects that we worked on, that we then used to train an algorithm that we developed called lunasea that compresses that data and can do predictions on the fly. So yeah, here's some really nice tidal currents in Grand Passage. I can click and get a forecast. We use this a lot for marine operations planning because you basically have kind of 15 minutes to half an hour to do anything. Yeah, so it's actually kind of getting towards the end of the ebb right now. That's flood. Oh, sorry, end of the flood, and then it'll go ebb. And yeah, so that's the Bay of Fundy model. And I only have a few more minutes before I have to go, so I'm going to switch back to the other presentation. And yeah, and then the other thing I wanted to talk about is through SOAR, which is not-for-profit that I work with, and in particular from Lunenburg, where we're set up really well to provide full services, or whatever parts of a service could be useful to support deployment of buoys. We've got a great relationship with our neighbors, Ironbound Rigging, so they've got all kinds of, rope and shackles and experience, splicing and doing things like that. So we can put together wave buoys quite efficiently there. And then we've got several small vessels that we use for deployments. This boat here called the Grand Adventure is a 28-foot Cape boat that's set up with hydraulic winch and hauler, so we can recover anchors quite easily and move it around the province. And then we also, for our higher speed chasing down buoys that go adrift, or any other operations that can benefit from a rib, we also have a Hurricane 733, which is a nearly indestructible boat that can go through a lot of weather, and it's got a nice little kind of wheelhouse shelter on it as well. And yeah, just questions and discussion. Unfortunately, I've got another meeting that starts in a couple minutes, so I'm short on time, but really appreciate the opportunity to present and talk to you all.